Okay, now we have 13. Okay, I'll give you another 2 or 3 minutes to wait for your friends. I hope that before today is the presentation 1 for your water treatment plant design. So I hope before you start your presentation, I want the group to open the camera, to on the camera so that we can see the group members. Just for a while, so that we can see the group members, and then you can start your sharing your presentation slide. Okay. As I mentioned, each group will be allowed to present 15 to 20 minutes, and then followed by question and answers. And also, students also can ask questions to their friends. Okay. 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 Now we have 20 students in the class. I think we can start now, because otherwise we won't have enough time to finish the presentation. Because this is very important for us to evaluate whether the river that is selected and also the parameters are possible or not to be for you to build your treatment plan for the project. Okay, I think I will start with group number 1 first. But for the final presentation, not necessarily that I will follow the order. But for this group, okay, I will start with group number 1. The members Muhammad Amirul bin Muhammad Razali, Nur Farisa Hafiza binti Hishamuddin, and Kim Yuns. Can you all on your camera for a while so that your friends will be able to see your face?
Okay, Prof.
Okay, and then you can share your slide and start the presentation. Okay, Farisa, Amirul, Yuns. Oh, okay. Okay, so I'm happy that all of you have started your discussion. I hope, hopefully. Okay, you can start your presentation now.
can you see our slides? Prof, can you see our slides?
Yes.
Oh.
Yes.
Let's
It's
start.
clear. Okay, you can start now.
Okay, Assalamualaikum and good morning. I bid to all my friends and Prof Fatihah. So we are from Group 1 to present about our water treatment plant project. So this is our group member. Okay, now I pass to my friends to continue this part.
First is our instructions. I want to tell you about the background. Langat River is 78 kilometers long with a catchment 2,350 square kilometer and originates from the Titiwangsa range at Gunung Luang. Second, it is one of the most important low water resource for drinking water, recreation, industry, fishery, and agriculture in Selangor State, Malaysia. Langat River used as water supply if only conventional treatment is carried out. Fourth, the source of the Langat River pollution are identified as industrial discharge, domestic sewage from treatment plants, construction projects, and pig farming. Last, Langat River is classified in Class 3. This is the map of Langat River. And I want to tell you about target area Kajang 2. The circle, it is receives sewage from the Kajang 2 catchment, which covers an area of 6.5 square meters, comprising Kajang 2, Kajang 3 Timur, and Section 5 Pandalu Barubangi. And water treatment plant Kajang Utama. It is located in Tamang Kajang Utama, 43,000 Kajang, Selangor. The plant serves wide range of customers, which include residential premises, commercial, industrial, and government premises.
Okay, now my next module, now I will explain about the water quality analysis. So this is the water quality standard in Malaysia. So in Malaysia, we have 5 class, which is class 1, class 2 divided into 2 parts, which is class 2A and class 2B, class 3, class 4, and class 5. So this is the continue of the standard quality standard in Malaysia. So as you can see, this is the DOE Water Quality Index classification. Because we have a student exchange members, so we try to compare the water quality standard in Malaysia and also in Korea. So this is the value for the water quality standard in Korea. So this is the table for the water class and use. So as for class 1, it is the conservation of natural environment. Class 2, it is need a conventional treatment required. Class 3, it is a water supply. It is extensive treatment required. So like my friend as present before, say that the Langat River, which is the river that we choose, is in category class 3. So later, I will show you the result of each parameter in our Langat River. So this is the location of the sampling location. So there is a 10 station. So I can see that this all 10 station is along the Langat River. So this is the value of the result from research in the research journal. So there is so after this, I will just show the average value. So first is the physical parameter. So the temperature is between 27.14 until 28.86. So when it in the standard regulation measure, it is in class 3, class 2A. And the TSS the value is between 89.47 until 90.29. So it is in class 3. However, for this parameter, we not found for the Korea standard regulation. Okay, next is the chemical parameter. So the value of the Sungai Langat is 6.8 till 7.49 for the pH. So in standard regulation measure, it is in class 5. So in the standard regulation for Korea is in all class because the value is have in range of all class, as you can see at this table. Okay, next is the BOD. So BOD, the Sungai Langat is in class 2 for the standard regulation measure and class 1B for the standard regulation Korea. So class 1B is category for a good river if follow their standard regulation. Next is COD. So COD is in category class 4 for measure and class 6 for standard regulation Korea. So classic is a very poor condition. And then lastly for the chemical parameter is the DO. So DO for the resource journal is we get the 3.82 until 5.9 and it is in class 5 for measure standard deviation and class 2 or class 3 for the standard deviation Korea. And lastly is the biological parameter. So the value is 1,100 until 36,000. But however, in this parameter, we doesn't find the standard deviation for both Korea and Malaysia. But this is for additional information. My FYP is I researched this Langat River to find the bacteria. So during the research, there's a lot of bacteria, especially bacteria escape, and 4 common bacteria such as E. coli, Shigella, Salmonella, and Pseudomonas aeruginosa. So this bacteria are found in the Sungai Langat. So this is just additional information. Okay, I think that's all from my part. Now I pass to my friend to continue what is mentioned below.
The next step is to the uniform technical guidelines of water rectification and plumbing are used to obtain the value of the average daily water.
Fatihah, maybe you can increase the volume.
The next step is to estimate the rate of water demand. The Uniform Technical Guideline of Water Rectification and Plumbing are used to obtain the value of the average daily water demand. As listed in the table, there are 15 different types of premise with different value of the average daily water demand. The water demand and consumption may vary considerably within each of these housing groups based on the property characteristic. For example, terrace house has the value of 1,300 liters of average daily water demand, while semi houses have the value of 2,000 liters. Next. The next slide is about the calculation of the water demand. For example, the terrace house density of 1,500 units is multiplied by the average daily water demand of 1,300 liters per unit, and then is divided by 1,440 minutes and 1,000 liters to obtain the estimated water demands in minutes. As a result, the estimate water demand for terrace house is 1.35 cubic meters per minute. The water demand for other buildings is then calculated using the same step as shown in the table. The total water demand in this area is calculated by adding the total water demand for all 15 buildings and premises. Next. As a conclusion, The Kajang 2 catchment area estimated water demand is 5,521.75 cubic meters per day, which is equivalent to 5.92 cubic meters per minute. That's all. Thank you.
Okay, thank you, Group 1. Good. Okay, we have listened to the presentation about Langat River. Okay, can I have a look at your comparison with Korean guideline just now?
This one.
No, the one with the very good. This one, status character. Okay, in Korea, do you specify the water quality that is used for that will be used for drinking water source? Do you specify which quality that need to be? Yeah. So which quality that you allow the resource water to be used for your national drinking water treatment plant?
Actually, I have prepared that for the water drinking water standard. Wait, I show you. This is the water quality standard for drinking water in Korea. But for the data that we get from the journal is not much stated to compare with this table. So that's why I'm not presenting. For example, like
Okay. Actually, in Malaysia, I agree that you will use the water quality, the class 3 water quality, to be treated for your for your water treatment plant. But in real case, in Malaysia, we only allowed, because our water treatment plant, they don't have they only have conventional unit operations. So that's why if the water quality is not in class 2, they will automatically stop the treatment of the plant. Do you notice that? Sometimes in Malaysia, they stop the treatment plant. It's not that we don't have the technology, but we maintain conventional technology to ensure that we have a very low water price. That's why I want to know whether in Korea, do you specify any quality that need to be adhered to before you choose the water source for your water treatment plant? Do you have the same in Malaysia or different? Yuns, do you know that? You're not sure?
Yes, I'm not sure.
You have to check, okay? So because this is a knowledge. In Malaysia, you only choose water quality class 2 to be treated in your drinking water treatment plant. Although in your case, I want you to do more, meaning that whatever source, I want you to be able to clean up to the drinking water standard. But in real case, in Malaysia, you will only allow those with standard 2. Otherwise, that's why, do you hear many times that we stop the operation of this water treatment plant? Usually that because they don't comply to standard 2 in water quality. Okay, so what are the parameters that will that are higher just now? You show me higher than the. Okay, so you have this pH is okay. So BOD class 2, need to be need a conventional treatment. Oh no, it's 1, 2, 3 class 2. Okay, yes. COD class 4, so meaning that I hope that in your next presentation and in your report, you'll be able to tell why this COD becomes high. I mean, what are the sources of this COD to the river? Okay, you'll be able to tell by looking at what are the activities along the river bank. Okay, and dissolved oxygen. Yours, what is yours?
3.82 until 5.9.
3.82 to 5.9. So it's quite low. Okay, actually this one class 5 should be here, right? Class 4 should be here. The value your research journal, it's not here. It should be here. Okay. Okay. Yes. I understand why you said it's class 4 here. Yes. That's right.
I just take the maximum.
Okay. So this is class 5. Dissolved oxygen is very very polluted river. Okay. Next just now your table and E. coli. Okay, E. coli, even though it's not in the standard regulation for water source, but for drinking water, you have the standard, right, for E. coli. So meaning that whatever that you treat, you must get up to the standard drinking water after the treatment. You have to make sure that the disinfection of your water treatment plant achieve the level by the standard drinking water in Malaysia. Okay, good. Thank you, Group 1. So you can start. Design your treatment plan for the amount of water that you have calculated just now. Okay, thank you, Group 1.
Thank you, Dr.
Okay, now is Group 2. We have Muhammad Fakul bin Zul Hairi, Nur Syahira Syamimi, Adiyatma Fauzan Rafi, and Fatika Ikrima Irza. Okay, so can you, the 4 of you, can you please on your camera so that we can see you? Okay, Syahira, Fakrullah, Fauzan. Okay, Fauzan and Ikrima. Ikrima and Fauzan, where are you? Are you in Malaysia or in Indonesia? Ikrima, where are you?
We are in Malaysia.
Oh, in Malaysia. So you'll be going back for Hari Raya?
No, we stay in here.
Oh, you're staying here. Okay, Fauzan as well. Oh,
yeah.
None of you. Okay. Okay, good. Okay, okay, we can see all of you. You are in what college? Ikrima?
College Ibu Zain.
Oh, College Ibu Zain. Fauzan also in College Ibu Zain. Oh, all the mobility students in College Ibu Zain. Okay, Syahira and Fakrullah, are you in UKM or at home?
UKM, Prof.
Oh, UKM. All of you, year 4. Okay, good. Okay, you can start your presentation now. You can start sharing your slide. Group 2, Klang River. Okay.
Alright. Okay, thank you, Fauzan. So, Assalamualaikum, a very good day to Prof and fellow friends. So, we are from Group 2. We are going to explain a little bit about Klang River. So, for our water treatment plan design project. Next. So, basically, for Klang River, the location is located in, the Klang River begins from Ulu Gombak Forest Reserve. And then there are 13 major tributaries, which included Sungai Kelang, Basin, Sungai Batu, Sungai Gombak, Sungai Ampang, Kerayong, Kuyo, Pensyarah, and Sungai Damansara. So basically the river basin is 1,280 km square and the river length is 120 km. It's estimated like that lah. Next. So it is actually located at central Selangor on the west coast of Peninsular Malaysia. So as I mentioned just now, it is 120 km long, about area covers 1288 km square, included the most of federal territory of Kuala Lumpur and parts of the state of Selangor. So it is actually the fourth largest river basins in Malaysia out of 7. Next. So annually, the basin receive rainfall during northeast monsoon, November to March, southwest monsoon, May to September, and there are two intermonsoon periods, which is April and October. So with an average annual rainfall that range from 1,900 millimeter to 22,600 millimeter. The monthly mean temperature range from 26 to 28 degrees Celsius, with the daily mean humidity is about 80 to 85%. For land use, we can conclude that the upper catchment, it consists of heavy and light industry, which is dominated there. And in Gombak district, followed by infrastructure 15% and small businesses 15%. So the land use change as the river flows. The reserve at the central section of the basin. So for the central flow, for the center, the land use changes predominantly livestock 23%, agriculture 20%, industry 20%, followed by infrastructure facility 10%. Meanwhile, in the river mouth or the lower part of the river is focusing on the residential area and the business use. So that's all for background. So I pass to my friends.
Alright, so the next is the quality of the source of the water from the Klang River. So here you can see the data we get. So for the BOD is 4.83 milligrams per liter. For the COD, 50.61 milligram per liter. For the total spent solid is 50.9 milligram per liter. And for the ammoniacal nitrogen, it's 1.97 milligram per liter. So this is the index that we use to qualify what class they are from the ammoniacal nitrogen, BOD, COD, and TSS. So after comparing this and this, we get that this is the class. For the BOD is class 3, for the COD class 2, for the suspended solid class 3, and for ammoniac is class 4. So according to the Malaysian guideline, this is the class and the uses. So for class 1 is for conservation of environment, water supply, fishery. For class 2A is for supply, fishery, recreational use, and body contact. Class 3, vessel supply and fishery as well. While class 4 and class 5 for irrigation. Okay, for the next one, I'll pass it to my friends.
Klang River water demand. There are 3 dams that provided treated water for domestic and industrial usage in for Klang Valley. The Klang River provide water for Klang Valley residents and industrial use. There are 8 million population in Klang Valley with growth rate 2.68. The 3 dams are first, Klang Valley Dam provide 145 million liter per day. 38.3 million gallon per day. Its holding capacity is 25.104 million liters. The dams also function as flood mitigation. Next. The second is Batu Dam. Batu Dam provide 114 million liter per day. Its holding capacity is 30.2 million liters. Next. Tasik Subang Dam provide 21 million liters per day of treated water. Its holding capacity is 30.600 million liters. Next. These are the location of the dams. Batu Dam in the center, the right one Klang Gates, and the left Tasik Subang. Next. Okay, this is the waste water treatment plant within Klang River. There are 6 of them. Bukit Nanas, Sungai Batu, Wangsa Maju, Gombak, Ampang, Intik, and Sungai Rumput. All of them is operated by Puncak Niaga Sembilan Berhad, and their design capacity is 355.37 million liter per day. So this is our demand that we will use in this project. Thank you. That's all from us. Thank you.
Okay, group 2. Okay, so you are going to build a water treatment plant in Klang River, but okay, for the design capacity, you're talking about 355.37 million liter per day. Is it true?
No, we pick Gombak 31.37 milliliter per day. In this project, we use 31.37 million liter.
31.37.
That one in Gombak. The 355 is the all of the WTP design capacity.
Okay, so 31.37 million liter per day. Okay, so actually just now is the ammonia higher than the guideline, the ammonia? Okay, see, comparatively, what is the standard guideline? So ammoniacal nitrogen. Okay, okay, so you have to make sure that. Okay, now actually ammonia is in standard 4, right? Class 4. The ammonia in class 4. Okay, so actually you don't have to follow whatever the Puncak Niaga they have already built the treatment plant and the unit operation, but I hope that your treatment plant will be different from them. Okay, I want you to be creative in using whatever the unit operations that we'll be dealing with after this. Previously, we have learned about filtration and also coagulation, flocculation, and we will have more on unit operations about absorption, membrane. So don't look at their treatment plant. Okay, you just use the wastewater, the water quality criteria that you found in Klang River, and use it for your own design treatment plant. Okay. Okay.
Okay, Doctor.
Anything that you want to ask?
So far, okay, bro.
Okay. So just now I think yeah, because Puncak Niaga, I don't think they use I think Puncak Niaga they treat the ammoniacal nitrogen? Because usually whatever the water source for Malaysia is when they have in class 2. I think the one that you select maybe the unit, the water quality. Where did you get the water quality from? The water quality criteria. Where did you get this one here?
For the quality, we use the search from the State of the River Report 2011.
Muhammad Shamir, yes, please record. Yeah, please record the class. Yes, you can record. Where do you get the quality from? Sorry.
For the research, we got it from the State of the River Report 2011.
Okay, so you have to put the references. Okay, you have to put the references that you have used, and in your report and also in the presentation, you should state the reference from where you get the data from. Okay, these are the quality, the parameter that exceed the required standard, right? But in your presentation of water quality criteria, I want you to put whatever the other qualities that have been monitored for that river. Okay, so this one you only list the 4 that are higher than the water quality standard. Okay, so after this, please put references. The reference is not for the water source, right? So what is the reference just now that you use? The water report? Ikrimah, what is the What is the reference?
For the reference, we use it for the state of the river report for 2011.
DOE report. DOE report.
It is river report, state of river report 2011 from Lembaga Urus Air Selangor Luas.
Oh, okay. So, but do they use this as a water source? No. It is not used as water source, right? From the report, they just report the quality, but not saying that this is the water source used in Malaysia, is it?
Yes.
Good. So they don't use this water source because in Malaysia they make sure that they will only use class 2 water source for our treatment plant. That's why in Malaysia actually the price of our water, treated water, is very, very low. That's the reason why it's very difficult to implement water reuse, because usually when we make any system or we just we try to reuse usually the tap water is cheaper. So that's why we don't have any problem. That's why reuse water in Malaysia is not that widely used. So, but in your water treatment plant design, I want you to be able to, if you think that it's good to, this is not a wastewater. So, I mean, it's about wastewater treatment plants. Usually, they can also reuse whatever water that you have treated in your plant. But here, this is water treatment plant, so you don't have to reuse. Okay. Okay, thank you, Group 2. You can start designing your treatment plant. Okay, we go to Group 3. Group 3, we have Ahmad Yusuf bin Johari, Afrina Yusra binti Anwar, Arshad Raihan Rosihan, and Hairunisa Hilmi Iklima. Okay.
Assalamualaikum.
Waalaikumsalam. I cannot see your name lah. The first one, who's talking?
I'm Afrina.
Akrima. No.
Afrina.
Iklima.
No, Afrina.
Afrina. Okay, Afrina.
Yeah.
Afrina. Okay, Afrina. Arshad, where's Arshad? Which one is? Oh, Arshad. Okay, Ahmad Yusuf. Yes, I know. So, Raihan. Okay, Raihan. Okay, you can start now.
Raihan and Iklima start first.
Iklima.
Okay, Assalamualaikum warahmatullahi wabarakatuh. Good morning, good luck to all of us. Okay, so we are from Group 3. We will present about water treatment plan design project, a study case of Bedadung River water quality is Java, Indonesia. Next. So in our group there are 4 members, and there is Ahmad Yusuf bin Johari, Afrina Yusra binti Anwar, Arsyad Rehan Rosian, Khairun Nisa, and Hilmi Iklima. Next. Next is table of content. So our group divided 3 part section. So in first section it discuss the introduction and water source background. On the Okay, the Badadung River is one of the most and the second section is water demand source for community, and third section is water source quality. Okay, next to first section. Next. The Badadung River is one of the most strategically important river in East Java and is located the Badadung Basin of Jember with a length of 46,000.875 meter or 161 kilometer. The Badadung River flows from the slope of the Iyang Mountain across downtown Jember and empties into the Bay Indian Ocean. Badadung River has springs located in the middle of the Iyang Mountains. Then in the eastern part comes from the Mayang River, which also get a source of water from the Rawang Mountains. While on the south side of the Badadung River gets its water source from the Bondoyudo River, which drain water from the Semeru Mountains. Next, maybe can be continued my friend Iklima.
Okay, next slide, please.
Okay, Iklima.
Okay.
Okay, the next slide is the facts about Badadung River. The first fact is Badadung River has an important role in water demand of the surrounding community. The water demand are such as for household purposes like washing, bathing, or toilet activities, and it also used for agricultural purposes. The second fact is about Badadung River water characteristics. Because of the activities around the Badadung River deteriorating due to the outflow from household waste and agricultural land. Local residents' activities such as bathing and washing contribute to the turbidity of river water through the use of soap and detergent. At some point around the Badadung Basin, it smells unpleasant. And the last fact is the Badadung River has good function to biodegradable pollutant reduction. It is indicated by reoxygenation rate bigger than the oxygenation rate of the Badadung River. Next slide. Okay, the second subtopic is water demand and resource. Okay, as you can see, in the right side is the map which of Badadung River located. It is located in Jember, and the river passes through an area in Jember that includes the Patrang, Sumbersari, and Kaliwates districts. The land used in Badadung watershed comprises forest settlements, paddy fields, and grasslands. It is used by community and stakeholders as a source of both raw water and irrigation water. Therefore, it is used for washing, bathing, and latrines. And next slide, we'll continue with my friend.
So the target area for that we collect the water demand is at Tega Besar Permai 1, which located at Tega Besar in Kaliwates Jember Regency. There are 16 type of area which include houses, market, shop, recreational, office, education institution, hospital, hotel, and place of worship. Then the average daily water demand that I obtained from the guidelines and nature standard, and then the density is we assume, and then the Q, the second last row is we get that by calculate the average daily water demand times by the density and then times with 1/1000, and then we calculate the Q at the last row. The Q times with 1/1440. And then we got the total of flow rate of every area. And then next, I pass the presentation to Amrit.
Alright, Assalamualaikum. Okay, next slide. So we were talking about water source quality, and from the research, the study was carried out in the Bedadung River, specifically in the urban segment of the Jember, and it has 5 stops, which is Selamat Riyadi Street, Mastrip Street, Bengawan Solo Street, Sumatra Street, and Imam Bonjol Street. Alright, next. Alright, this is the research data. As you can see here, the temperature is 28.9 and TDS is 148, TSS is 1.36, pH is 8.17, COD 4, BOD is 0.89, TO is 5.48, and ammonia is 0.032. So actually, if you look at this data, we can simplify that most of the quality, most of the parameter is within class 1. But if we're talking about national quality standard, we have phosphate, cyanide, cyanide, total coliform, and facial coliform, which is exceed class 1 standard. Next. Alright, this is based on the Indonesia government regulation number 82, 2001. As we can see here, as I said before, most of the class is class 1, except for phosphate, cyanide, and total coliform and facial coliform. And the examination of the water quality of the Bedadung River found that the physical, chemical, and microbiological parameter generally within class 1. But the Bedadung River is categorized as class 3, and it is not viable for use as a source of clean water and drinking water. However, almost 90% of the 35 parameter, this is part of the parameter from the research. And almost 90% of the 35 parameter found to be a good and can thus be categorized as meeting the class 1 quality standard. Right, next. However, if we look to the national water quality standard, we can see that there is a similarity from NWQS and the Indonesian regulation, and we also classify this river as class 3 based on Malaysia standard. And according to the Department of Environment DOE standard, we can classify that as class 1 because we have ammonia, COD, BOD, pH, TSS, is all within the class 1. And so that's all from us. Thank you.
Okay, thank you, group.
Okay, this one, Prof. This one is just the what you call it? What I think need to be improved based on the data that we get. Right, that's all from us.
Okay, thank you, Group 3. Okay, very interesting that you look at this river because actually the river is from the mountain, right?
Yes.
It's not a very clean river, but finally that's why sometimes if you want to use it for how they class the river source, the water source, just to first just to look whether it's suitable or not. But once you look at all the parameters of drinking water, you can find that they need treatment, even though if in Malaysia case it's in class 1 without treatment. But now you look that they have this phosphate, cyanide, and coliform, right? Coliform.
Yes.
And it's interesting that when I look at coliform, it's high, but the amount of ammoniacal nitrogen is low. Usually, if you have high coliform, meaning that your ammoniacal nitrogen also is high. Okay, because usually they come together due to urea, because all the phases from warm-blooded animals, they have this ammonia, and at the same time, they will cause this coliform. Okay, so I want you to look carefully at this river and try to find whatever the land use, how they come out with this quality of river. In your, you design your treatment plan, and at the same time you look at the land use of the river bank. Why this coliform is high, but ammoniacal nitrogen is low. Okay,
Alright.
so it's very interesting that you look at different unit operations, maybe compared to the previous one that you have almost the same. You have ammoniacal nitrogen, you have COD, BOD, but now you have phosphate, cyanide, and coliform. Okay. Okay. Thank you, Group 3.
Right. Thank you, Prof.
Okay. Okay. Now we continue on with Group 4. Okay, Group 4, we have Muhammad Amir Ashraf bin Syabullah, Nur Syahima binti Jumali, Laksono Rafi Abrar, and Binti Alifia. Okay. Okay, Muhammad Amir.
Hello, Assalamualaikum. Dengar ke?
Dengar.
Screen
Muhammad Amir. Muhammad Amir, which one? Muhammad Amir?
Saya Muhammad Amir.
Oh, you Muhammad Amir. Okay. Nur Syahima. Okay, Nur Syahima, Rafi, and Alifia. Okay. Okay, you can start your presentation.
Start.
Okay.
Assalamualaikum to Dr. Fatihah and my fellow friends. Today, we would like to present about the case study of JRB, which means like Johor River Basin, design of the water treatment plant. So our group member consists of 4 people, which is me, Amir Ashraf, and Alfi, Syahima, and last but not least is Rafi. So the content consists of introduction, location of the source, community to be served, water quality and characteristic, and current condition at the site. So as we all know that water serves a multitude of use, as the various of use have grown in diversity constrained by the fixed quantity available and significant interaction of use and use of water has also developed. So in developing country like Malaysia, rapid change are continually taking place. This include population growth, urbanization, agriculture, mining and logging activity, and industrialization. So Johor has reached a stage where the demand for raw water exceed the water availability, with the increased demand for water from the growing population, industry and agriculture sector. So this project was carried out at Johor River Basin to check the characteristic, source and the community to be served, carry out all the treatment that involved. So prepare the conceptual design for the treatment and calculate the estimate system cost. Next. So here is the location of Johor River Basin at Johor Bahru. So I will pass to my next slide.
Okay, the Johor River is the main river in the Malaysian state of Johor. The river is 122.7 km long with a catchment area of 2,636 km square. The Johor River Basin covers approximately 14% of Peninsular Malaysia state Johor. The river and its tributaries are key water supply sources not just for the state but also for neighbouring Singapore. The Johor River in Kota Tinggi is used by Syarikat Air Johor and the Public Utilities Board of Singapore for about 250,000 cubic meter per day. Both projects have been in existence since the mid-1960s. Furthermore, the Lingga Dam, which was built and occupied in 1963, complements the water supply to both Johor and Singapore. Next. GRB is an essential supply of water in Johor for drinking, industrial and agricultural processes, accounting for up to 55%, which is 927 million litre per day of total water demand in the state. According to the 1962 water agreement between Malaysia and Singapore, Singapore has the right to draw water up to 1,100 million litre per day, roughly half of Singapore's daily drinking water requirement. Water quality in GRB River is highly impacted by land development within the basin. There have been several instances of excessive ammonium concentration in particular. Such incidents have even resulted in the shutting down of 5 water treatment plants in 2019 and disrupting water supply to tens of thousands of residents in Johor. So next. Okay, this is guideline water calculation provided by Suruhanjaya Perkhidmatan Air Negara. So for our calculation for water demand, we are referring to this table. Next. So there are several types in it. Before that, our target area is in Kota Tinggi. So there are several types of area, which is in the Solteras house, Semidi, bungalow, medium cost flat apartment, low cost shop, recreational, wet market, royal market, day school, semi-media workshop, petrol, farm, hotel, and stadium. So the decision for making this calculation is mainly by assumption. So all the value I input in here is by assumption. So we got 24,131 meter cube per day, and we got 16.76 meter cube per minute. So that's all. Next. Okay, let me continue. So this is the water quality and characteristics that we find on Johor River. And for the physical is turbidity and temperature. So the number of observation of turbidity and temperature is 44.5 and 42.6. And for the chemical, the pH number of observation is 4050 and the COD is 4025, and for the biological is equally and coliform. It is the same 3 and 87 number of observation, and so the average of the result or the number of the turbidity is 64.3 NDU. The temperature is 27.9 degrees Celsius. For the pH is 6.29, and for the COD is 13.7 ppm. For the equally is 1.00 mpn per 100 milli, and for the coliform is 41.00. Next, please. Okay, so here's the national water quality standard that we found on the journal. There's the parameters for the class. There are like 5 class. Okay, next.
Okay. Let me continue our presentation. Current conditions at site. According to Pak Hui Journal 2020, current conditions site at Johor River. GRB or the GRB or Johor River Basin spans over 4 districts: Kota Tinggi, Kluang, Kulai Jaya, Johor Baru. Johor is a fully developed commercial agriculture state. The most common land use in GRB is large-scale oil palm plantations, 71%, and oil palm plantations are the main agricultural sector in Malaysia. However,
High nutrient concentration from fertilizers used in oil palm fields can be carried into surrounding waterways during storms, causing pollutions. And for the climate, in the GRD is classified as tropical monsoon with significant precipitation from November to January and frequent floods in December. Okay, thank you. This is from our group. Thank you.
Okay, thank you, Group 4. Just now, you are doing Johor River, right? Okay, can you once again highlight what are the parameters that exceed the guideline standard that you want to especially pay attention to in your design of your water treatment plant? Which one? 64.3. I don't remember. So can you put side by side? So which one will be the parameters are higher than what you want? And what water quality actually this river is according to this water characteristics?
Okay, so doctor, in the journal, it says that the water quality is for the class 2 in the journal.
Class 2. Class 2 meaning only conventional treatment. Okay. So if you can have other parameters that can make the river into class 3, then you will be able to design your treatment plan will be more exciting because you will have to show us that you are able to treat other parameters not using the conventional treatment. Maybe these are the this is only part of the water, the river, right? Maybe you can find a bit along the river. Maybe you can find a bit polluted section of the river so that you can use the river water quality to design your treatment plant. Can you do that? It's a big river, right? Johor River. Because just now you explained to me that the land use mainly is used for palm oil plantation, and also you have this fertilizer. Because in this one, oil palm plantations and agricultural sector, so you can see that there will be a lot of runoff non-point sources from all these oil palm plantations and agriculture sector. But when you show me the table of the water quality, it looks nice. It's in class 2, so you need only conventional treatment. So it's this land use doesn't really show us the real quality of what you expect from this So maybe you need to find in Johor River the section that is a bit polluted so that you can use the water source for your treatment plant. Is it possible?
We try, Doctor.
Okay. 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 Thank you, Group 4. Okay, we continue. Okay, we continue with Group 5. Group 5, we have Muhammad Hizami bin Kamaruzaman, Nur Fatina Ziha binti Muhammad Yatim, Soma Dinata Arwin Ilham, and Nauli Evita Emanula. Okay. Okay, now Group 5.
Okay, ma'am.
Hello everyone. Assalamualaikum. We are from group 5 and we will be presenting about our project. So our group consists of Izami, me, Evita, and Fatihah. So the background, what is our project about? So our project has three main topics to talk about, which is the water demand for the community, specific source of the water supply, and the quality of the source. Where is the project location? Our project is located at Kuantan River in Pahang. So the river starts from Sungai Lembing, which is like the start, and it flows through Kuantan City in Pahang, and the final destination is in South China Sea. It is like 86 kilometers long.
Okay, this is the target area that covers Taman Bukit Rangi for water supply. Taman Bukit Rangi consists of 50 units of double-story house, 164 units of single-story house, 10 units of shop house, 1 unit of budget hotel, and 1 unit of secondary school. So we know that the water estimation of water demand it helps to determine the quantity of water that will be used to generate various demand pattern. So most of water demand from here we can see that arises for residential, institutional, and public uses. The water demand as per calculated that follows pan guideline is that the total daily water demand is 0.25 meter cube per minute and total peak water demand is 0.61275 meter cube per minute.
Okay, next is the specific source water supply for Kuantan River. Kuantan River is one of the important river basins in Pahang and covered 1,630 kilometers square of catchment area, which started from forest reserve area in Ulu Kuantan district towards the South China Sea. Kuantan River is the largest river in the capital of area Pahang, Kuantan, and the major source of the water supply for domestic, industrial, and agriculture usage, providing 350,000 meter cube per day. Example of tributaries river located around Kuantan River are Pengorak River, Karang River, and Balok River. Next.
Who's next? Alifia?
Next is the problem in tributaries river along Kuantan River. First is regarding the annual flooding. Kuantan River has history of experiencing the flood since past decades because of its tropical climatic condition. Torrential rain brings spilling over of river surface runoff, inundate low-lying areas, hamper human social and economic life. The secondly is located near industrial facilities. The river flow passes through the wide industrial facilities, which include steel industries, palm oil mills, and pipe coating and other development activities. Next.
Okay, before it's me, Evita Manula, but my device is kinda have trouble, so I want to continue.
Okay.
For the search quality of Kuantan River, the sample were collected in Kuantan River on duration February 2017 to April 2017, and in the Kuantan River there are 3 sampling stations. The first is Pengorak River, Karang River, and the last is Balok River. Next. Okay, for the first parameter is COD. The highest concentration is recorded in Pengorak River during the first sampling. The amount is 79.11 milligram per liter, and the high concentration in the second sampling is recorded in Balok River, which the amount is 76.78 milligram per liter. And for the lowest concentration is recorded in Balok River. For the first sampling the amount is 47.89 milligram per liter, and for the second sampling is 68.98 milligram per liter. And for the second parameter is ammonia nitrogen. The range of the amount is 0.99 to 2.03 milligram per liter for the first sampling, and for the second sampling is 1.4 to 2.3 milligram per liter. For the third parameter is total suspended solid that have ranged from 20.74 to 52.46 milligram per liter for the first sampling, and the highest was recorded in Balok River and the lowest in Karang River. And for the second sampling, the total suspended solid values have ranged between 11 to 22.72 milligram per liter. Next. And then for the fourth parameter is BOD, the highest was recorded in Pensyarah River and the lowest in the Balok River, which have ranged value between 0.42 to 0.71. And for fifth parameter is dissolved oxygen that have ranged in the first sampling is 4.59 to 5.35 milligram per liter, and for the second sampling is 1.28 to 5.37 milligram per liter. And last parameter is pH that have average value of 8.2 of Balok River, and for the lowest average it's recorded in Karang River that have value 6.2. Next. So this is the average for the first and second sampling that COD has value 66.8, the BOD have value 0.5, the pH has 7.75, the ammonia nitrogen has value 1.68, the DO is 4.15, and the total solid is 26.73, and below is the reference that we take the data from. Next. And so this is the water quality index classification that separate to 5 classes, like the others group already mentioned. Next. So for the Kuantan River, the water classes of Kuantan River, first for the COD is on level 4, the BOD is level 1, the pH in level 1, ammonia nitrogen in level 4, DO level 3, and total suspended solid in level 2. Next. And this is the water classes and uses separation of each class. That class 1 consists of conservation of natural environment, water supply that no need to have treatment, and fishery, and for class 2 have water supply 2, conventional treatment required, fishery in class 2, and recreational use with body contact, and class 3 have water supply 3 that extensive treatment required, and fishery 3 that common of economic value and torrent species livestock drinking, and class 4 for irrigation, and class 5 none of the above of this. Okay, next. Maybe that's all from us. Thank you.
Okay, thank you, Group 5. This is also good that you might be able to design a good treatment plan. Show me once again the quality of the river water. The quality just now when you discuss about, not this one, next slide. This one, okay. You can see here the source, the quality, it's quite, the COD to BOD, you have to also look whether your COD, the organics, the carbon source, is it from biodegradable, could be from a sewage treatment plant or from industries. You can see the look for BOD and COD ratio. What we found here, BOD is very low, but COD is 63.8, quite high. Then you should be able to tell that actually the organic carbon is from industries, not from, so it's not biodegradable. So meaning that when you design your water treatment plant, you have to be careful with the selection of your unit operation. And also you can see here, the ammoniacal nitrogen. Ammoniacal nitrogen is quite high, and maybe it's not from sewage treatment plant because your BOD is low. Your COD is high, but your ammoniacal nitrogen also is high. So ammoniacal nitrogen could be from industries. Okay, so this is interesting that you must be able to choose the right unit operation to reduce all of these parameters up to the drinking water. Okay, okay. Group 5. Now we continue on with group 6. You will learn a lot when you design your own treatment plant. Okay. Number 6, group 6, Suhail Azmin bin Saad, Muhammad Amirul bin Hasnan, Wahyu Jati Andreas Ariseto, Rustam Rania Mastura. Muhammad Amirul, is your father UKM lecturers? Huh?
No.
No. Okay.
Okay. Yeah.
Okay. You can start your presentation.
Nampak Doktor?
Nampak.
Yeah.
Ni all the Indonesian, they don't go back. You don't go back to Indonesia, yeah? For this festive season. You all will be staying here?
Yes, ma'am.
Oh, all of you?
Yes.
Oh, okay.
Visa belum turun, ma'am.
Okay, you can start now.
Alright. Assalamualaikum warahmatullahi wabarakatuh and good afternoon. We are from group 6 and we're going to present about the Melaka River. So my name is Muhammad Amirul and my group team is Suhail, Andres and Rania. So
Suhail, okay, Suhail, which one is Suhail? Suhail? Okay, Suhail, Muhammad Amirul, Arya Seto, Rustam Rania.
Yes, ma'am. Rania Mastura Rustam.
Rania Mastura Rustam. Rustam is your father, right? Oh, sorry.
Yes.
That's why I try to find it. You got both. You got Mastura, you got Rustam. So I don't know which one, whether it's a girl or a boy. Okay.
alright. First of all, I'm going to talk about a little bit about Sungai Melaka. So the main source of the Sungai Melaka is located at the end of Banjaran Titiwangsa, which is located in Tampin, Negeri Sembilan, and its flow into the Sungai Tampin. And the second branch start in Tebong, which is located in Alor Gajah district, to Sungai Batang Melaka. So those two rivers meet in the Gadek, which is in Alor Gajah district, forming the Melaka River. So the Melaka River is 40 km long. So the main function of the original Melaka River was as a source of water, food, agriculture, livestock, transportation, and employment. Now the state government is develop the Melaka River to be like the Venice of the East, which is one of its tourist program. So the famous the Melaka River cruise, which is 45-minute trips that which is 9 kilometer long. So the physical redevelopment has made the Melaka River more attractive. So next, I will pass to my friend to talk about the water quality analysis.
Okay, so the second one is water quality analysis. Next. Okay, so this is the parameter that we use for Sungai Melaka. There is a total suspended solid or TSS, and the second one is pH, dissolved oxygen, or we call it DO, and then biological oxygen demand or BOD, and chemical oxygen demand or COD, and the last one is ammoniacal nitrogen or AN. Next. Yeah, so this is the standard parameter. This is the standard parameter in Malaysia. First, we have a water quality index. So for water quality index, there is a value. So we can classify the water quality. And for the water quality, classified as 5 class. Class number 1 is for excellent water quality. And the second class is for good water quality, and for class number 3 is for medium quality, and class number 4 is for poor quality, and the last class is class 5 is for very poor water quality. And then this is the standard parameter for each parameter so that we can classify the water quality. And then next we'll continue with Suhai.
Assalamualaikum. So I will continue the presentation. So this the formula for calculate the WKI. Okay, next. Okay, so this is our parameter at the Malacca River, which is consist of 12 stations. So the highest DO is 6.66. Highest BOD is 4.5. Highest COD is 66. While ammonia is 1.2. For the suspended solid is 80. And last one for the pH, which is 6.88. Okay. So after we use the WKI formula for calculate the all parameter, we conclude that all of the station that in Sungai Melaka in class 3, which is the slightly polluted. Next.
Yeah, so according to water quality index value, Sungai Batang Melaka is classified in class 3, which is slightly polluted, which means the quality of the water is classified as medium water. So medium water can be used as a water supply, extensive treatment required, and fishery common of economic value and tolerant species, livestock drinking. And
So this is the water demand from the nearest area from the Sungai Melaka, from Alor Gajah. So we have domestic demand domestic demand from the urban area. We have population of shown there, and then the PCC is 245 liter capita per day, 260, 275, 286, 293, and 300. And then we have the total demand from the nearest year 2020. We have 118,69 million liter per day. Next. So we have the reference of titled water pollution and water quality assessment on Sungai Batang Melaka River by Egyptian Journal of Chemistry. That's from us. Thank you.
Okay, thank you, Group 6. Currently, is there any water treatment plant near to the river? Is there any water treatment plant? When you study the area, do you find any water treatment plant? Ada tak?
I think yes. Wait.
Oh, there's a water treatment plant.
There are some water treatment plant in near Melaka River, ma'am.
Near Melaka River. So they use the water treated from that treatment plant for drinking water supply. Is it? Or as a wastewater treatment plant or water treatment plant?
Water treatment plant.
Water.
Yeah, they use
it for drinking water.
It said it's production capacity of 50 55 million liter per day.
Oh, but they use the water from the Sungai Batang Melaka. But it's in class 3 here. So maybe not from that section. You have to study more about the source of the water quality. But this one I can see that could be from organic. So you need also to study a bit on the background of the land use near to the riverbank, because I can see that the BOD and COD are both high. So it could be from maybe sewage treatment plant near to the river. So meaning that if BOD and COD are both high, it's organic, then the type of treatment unit operation that you need to choose could be different if it's come from only COD, which is non-biodegradable. So this is something that you need to study about the water quality characteristic. Then you will be able to decide the correct unit operations for your treatment plant. Okay, thank you. Any question you want to ask me? And then maybe you check again that they have this water treatment plant, whether they take water from the Sungai Batang Melaka or from other source. Because this is in class 3. Okay. And it needs extensive treatment. And in Malaysia, usually we don't do extensive treatment for our water treatment plant. Okay. Number 7, group 7. Group 7, we have Muhammad Hafiz bin Kamari, Muhammad Dirham, Zahwa Safina Mutia. Do you all need to stop at 2? Do you all have any class after this? After 2?
No, Prof.
We have another 4 groups. Do you want us to continue, or you want us to stop at 2 and maybe 2 groups will need to present tomorrow? We have 7, 8, 9, 10. We have another 4 groups. So we need about 1 hour, but our class, we have to stop at 2. But if you want to continue, I'll continue so that you don't have to have your class tomorrow morning. Okay, you think about that first. Okay, group 7, you can start.
Okay.
Muhammad Hafiz.
Okay.
Muhammad Hafiz, Muhammad Dirham, Zahwa Safina. Okay.
Assalamualaikum and greetings to everyone. We are from Group 7, are about to present our first presentation of water treatment plant design project, where we chose Perak River as our study area. And here are the group members of our group. Okay. Yeah.
So our target area is in Teluk Intan. Teluk Intan is a town in Hilir Perak district, Perak, Malaysia. It is the district capital and largest town in Hilir Perak district and third largest town in the state of Perak, with an estimated population of around 120,000 total population. Next. Okay, the table showed total water demand in Hilir Perak for the low projection. The total value of the total demand increased from 84.3 million liter per day to 104.6 million liter in 2050 in prediction. And for the median projection, the total value increased from 90.3 million liter in 2010 to 121.8 million liter per day in 2050 in prediction. And the last, for the height projection, the total value water demand is increased from 90.3 million liter per day in 2010 to 151.7 million liter per day in 2050 in prediction. Next. So the figure show the projected water demand for Hilir Perak. Okay, next.
Okay, so I will continue. Next. Okay, Perak River is the second longest river in Peninsular Malaysia after Pahang River. The river extends from the mountainous Perak, Kelantan, Thailand, border of the Bloom Forest Reserve, and ends at the Straits of Malacca. As the second longest river in Peninsular Malaysia, Perak River is an important asset to the state of and people of Perak. It serves as the primary source of raw water and contributes to approximately 70% of raw water in Perak that is channeled to the population. This amounts to about 1,300 million liters of water that is distributed to 2.5 million residents in Perak daily. This number is expected to increase in the future as the population of Perak increases. Apart from this, the river also serves as one of the main source of livelihood for fishermen and is also a tourist attraction by providing tourist activities. The river also contributes in many other contexts in terms of benefit, profit, and serviceability. The Perak River was found to be polluted in terms of the presence of metals, including cadmium, heavy metals from industrial and agricultural activities along the river. Next. Towns along the river basin are Gerik, Lenggong, Sungai Siput, Kuala, Kangsar, Manong, Parit, Kampung Gajah, Pasir Salak, Teluk Intan, and Bagandatoh. There are several hydroelectric generators on the Perak River, Bersia generator, Kendaring generator, and Temanggor generator. Okay, next.
Next, we move on to the quality of the source. As shown in the slide is the location of the sampling sites along Perak River. And for our project, we focus on Station D, which is Perak River at Muara Sungai Bido, which is also located near to our target area, which is Teluk Intan. Here are some parameters and classification used for the water quality assessment. First one is the water quality parameters and the related method used. Second one is the sub-index and water quality index range, and also its corresponding classification. And last one is the classification of water quality based on water quality index. So first parameter used is dissolved oxygen concentration, and the result for the station 4, which is Muara Sungai Bido, is 2.24 milligram per liter, which falls within class 4. Second parameter used is biochemical oxygen demand concentration, and the result for station 4, which is Muara Sungai Bido, is 10 milligram per liter, which falls within class 4 also. And the third parameter used is chemical oxygen demand concentration, and the result for station 4, which is Muara Sungai Bido, is 7 milligram per liter, which falls within class 1. And the fourth parameter used is ammoniacal nitrogen concentration, and the result for station 4, which is Muara Sungai Bido, is 4.53 milligram per liter, which falls within class 5. And the last parameter used is total suspended solids concentration, and the result for station 4, which is Muara Sungai Bido, is 21 milligram per liter, which falls within class 1. And here is the simplified table, which is the water quality index of each stations. As mentioned earlier, we focus on station 4 since it is near to our target area, which is Teluk Intan. And the quality of water for station 4 can be concluded as class 3. However, on the basis of the water quality index itself, samples obtained from station 4, K4 falls into the polluted category. And thank you.
Okay, thank you, Group 7. Just now I saw in your slide, you are saying that the pollutant is from metals. Is it? I read somewhere just now. Okay. Here. The Perak River was found to be polluted in terms of the presence of metals. But you don't show any metal category pollutants?
For the journal, doesn't state the metals concentration.
Because when I look at the quality, water quality criteria, your BOD is high, your ammoniacal nitrogen is high. It could be from organic pollutants, could be from sewage treatment plants, because your COD is lower than your BOD. So this is very rare occasion where COD is lower than BOD. Only there's one reason why BOD is higher than COD. So meaning that when you say that it's from metals and you don't show any pollutant from metals, metals could be from industry, then you need to find out whether what you found from that journal is correct or not. Actually the source, you only use one source, is it? Wakif S2. What is the title of the journal, this one?
Water quality assessment at selected sites in Perak and Kinta River, published in 2020.
Oh, so they talk about these heavy metals somewhere along the river or at the site that you just show us just now?
Actually, in the journal there was no metal concentration assessment.
But where did you get about this metal, the presence of metal? Where did you get this info?
It is my another group members.
This one is from Wikipedia, Prof.
Oh, okay. Then you cannot combine. You need to be based on the water quality. Maybe Wikipedia could be from Perak River is how long? 400 kilometers. So maybe there's a section, the presence of metal. Maybe they have this water treatment plant where they put this aluminium sludge that use as coagulant, and they dump somewhere, and then you got this presence of metals. But at this section that you are treating, the one that you gave me, the water quality criteria, there's no indication that it's from metals. Okay, so you have to be consistent in providing the background and also the water quality criteria that need to be reported. Okay. Okay, thank you, Group 7. Okay, Group 8. So this, okay, Group 9 and 10, do you want to continue or you want to present your slide tomorrow? If you want to present tomorrow, then I will leave Group 9 and 10 for tomorrow. It's about maybe 40 minutes, both of this group. And then Group 8 is the last group for today. Okay? So maybe tomorrow at 9, we'll have our class as usual from 9 to 10, okay, for the Group 9 and 10. Okay? So now Group 8. Group 8, we have Muhammad Abid bin Mazlan, Muhammad Shimir Helmi, and also Zani Salsabila Putri. Zani Salsabila Putri. Okay. Do you have sister coming also for mobility program last year? Salsabila Putri? No? Oh, okay.
Sorry?
You have the same name. Last semester, I got last year. I got one student from Indonesia as well. Her name is Salsabila.
Yeah, my name is kind of common in my country.
Oh, okay.
Yeah.
What is Salsabila mean? Is it a name of a place or what?
I don't know. I don't know where it is. Yeah, it's kind of I don't know. It's just a name, I think. I don't know the meaning of it.
Maybe from film or something.
I don't know.
Okay, continue on.
Okay, thank you, Prof. First of all, Assalamualaikum warahmatullahi wabarakatuh. Good afternoon, everyone. We are from Group 8.
Today we're going to present about water treatment plant design project, and the location is Sungai Dua, Seberang Perai, Penang. Next. Okay, this group consists of 3 members, including myself. So it's Shima and Abid. Next. So Sungai Buda is the longest river in the state of Kedah, which is situated in northern peninsular Malaysia. It is located between Kedah and Penang. The river has a length of 180 kilometers, flows towards the southern area of the state, and has a catchment area of 4,210 kilometers. Next.
Catchment area of 4 kilometer square, is it? This one is catchment area. Okay.
Okay, sorry, Mama. Okay, next, downstream, the river changes its course towards the west coast after passing the confluence of the mainstream and its largest tributary, which is the Ketil River. There are 3 major tributaries of the Sungai Muda river system, which are the Ketil River, the Sedim River, and the Chapir River.
So moving on to water demand. So we need to evaluate the water demand for a certain community. First, we have to know what is water demand. Water demand has become an important component in planning and managing effective water resources. This indicates how vital is it to make water accessible for residents' needs, industries, and other commercial organizations. Since water demand is increasing day by day, the source of water becomes limited. So who is our target consumer? So based on Perbadanan Bekanan Air Pulau Pinang, in year 2020, population of state of Penang was projected to be 1.776 million people. And then about 46.6% of population, around 825,000 people resided on Penang Island. In a land area of 293 square kilometer, the Penang Island has insufficient raw water resources to meet water demand of 368. Treated water was pumped from SWTP in Seberang Perai to ensure water supply sufficiency.
Okay, Assalamualaikum. So this is the table for our target parameter. So there are 6 parameters to determine our Sungai Muda quality, which is pH, DO, BOD, COD, TSS, and molecular nitrogen. Then on the third column, it is an analytical method to obtain all the data for each parameter. So the method for pH is instrumental, such as the pH meter. And after that, for the BOD and the DO, we can use the wrinkle method, or simply we can use the digital meter. For the COD, we can use the dichromat or 3-day incubation at 28 degrees Celsius. For the TSS, the method is filtration and gravimetry. And for the last one is molecular nitrogen, we can use a phenoldisulfonic acid. So this is the standard water quality index by the Department of Environment, Malaysia. So we need to compare our parameter with this table, with this class range to identify our source is in the class within class 1 to class 5. So the crucial part is we need to know our WQI, which is water quality index. We need to calculate using this formula. So this formula we multiply all the sub-index parameter with the coefficient for each parameter, and we will get the WQI. So this is the sample of our sampling station. So DO is 3, BOD is 5, COD is 46, molecular nitrogen is 0.2, TSS is 42, and pH is 7. So we just substitute this data to the formula, and we get the result of 64. So we compare the result with the OE quality classification based on the water quality index. So at the last row of this table, there are a range of 60 to 80, which is it classify the water as slightly polluted. So 64 in a range till 80, so we classify it as the slightly polluted source. So this is our parameter for our source. So if we can see, the pH is on the class 2. For the DO is on class 3. In class 3. For the BOD is in class 3. For COD, they have 3 in class 3, which is a major. And for the TSS, most of them is in class 2, and ammonical nitrogen is most of it in the class 3. So based on the WKI calculation, we get all of the sampling station with 5 total of sampling station is in class 3, which is it classified. It is identified as the slightly polluted river. So it requires an extensive water treatment plant for before we supply the water to for the domestic usage. So from our group.
Okay, thank you, Group 8. Okay, so you have Sungai Dua Seberang Perai Penang. So you will treat the whole section of the river, right? You have 5. Just now you have 5 sampling stations,
Yes.
right?
Yes.
So actually, this river is in Kedah. This river is in Kedah.
Between Kedah and Penang.
Between Kedah and Penang.
And also this is the famous river. Okay, so at present they have already built treatment plant, is it?
Yeah. It is called as Sungai Dua Water
Treatment Plant.
Yeah.
So are you using the same source for your water treatment plant design, or you use different section of the river?
We use the different section the river to build to design the water treatment.
Okay, so because I see that some of the section is in class 3, right? So you cannot take for Malaysia, you cannot take as a water source. Okay. Okay, what else? Okay, you have provided all this. Okay, so you have this pH, DO, it's polluted with this organic pollution. Actually, no, the COD is high, comparatively higher than COD should be higher than BOD, but this one, I think not all of the pollutants are organic, because COD is 46 divided by 5 times. So it's much higher. So there must be pollutant from industries. And then ammoniacal nitrogen is not that high, maybe because of these industrial pollutants to the entering the river. So ammoniacal. So you have to be very selective in your unit operations for your water treatment plant. Okay. Okay, that's all. I think. Thank you, Group 8. So tomorrow we will have another 2 groups. 2 groups, Group 9 and 10 at 9. Okay. See you all tomorrow.
All right. Thank you, Prof. Thank you, Prof.
Okay. Okay. Welcome. Okay.
Thank you, Prof.
Welcome.
Dah ready present dah ni. Malang ni. Esok.